of 1. And 4 times 8 as exponent is I to the power of 4, then to the power of 8. And because we know I to the power of 4 here is equals to 1. So this is 1 times 1 to the power of 8 times I to the power of 1. And 1 to the power of no matter what number just equals to 1. So this is just equals to I to the power of 1, which is by here. Oh. By here, we have this is I to the power of 1, which just equals to I. And that's it. In this way, for I to the power of arbitrary large number, you can, by write the number as 2 parts. One part is the perfect product of 4 and the number, contains 4 as a factor, and the second part should be the remainder to divide the exponent by 4. So it's either 1, 0, 1, 2, or 3. So more or less this tells you for any I to the power of large number, you always can write it as I to the power of 4 to a certain power, multiply with I to the power of one of these 4 cases. So after all, I to the power of a large number always equals to 1 or I, or negative 1 or negative I, one of these 4 results. So that's it. That's the first part I want to talk about. And next, let me have a new board. Oh. Oh, it looks worse. Let me just simply copy the important part and then delete everything. So the important facts are I to the power of 0 equals to 1, I to the power of 1 equals to I to the power of 2 equals to negative 1, I to the power of 3 equals to negative I, and then I to the, maybe one more, I to the power of 4 equals to 1, and then since just repeating. So now let's see, what if we have not a monomial about this variable, not only I to a certain power, but a really polynomial? So we're going to introduce this concept. Oops, sorry. The complex number. A complex number is just something looks like a plus bi, where a, b are real numbers. So for example, a complex number example of complex number can look like 2 plus 3i. And because a, b are just real numbers, they may be negative, may be positive. So we also can have things like negative 5 plus I, when a is negative 5, b is equals to 1. And also, like, for example, we may have 3 minus 2i, when a equals 3, b equals negative 2, and so on. So more or less, a complex number is just a degree 1 polynomial of I. And not as our regular polynomial. In the standard form of polynomial, we know that we should write the variable term first. So it should be b times I plus a, somewhat like that. But for complex number, or for the special variable, the imaginary unit, we always write it has second place. So you can consider this as just a degree 1 polynomial of our new variable in a special form. So the variable came second, the number came first. So now we have the definition. Now we can calculate the basic operations on complex numbers, thus plus, minus, multiplication, and divisions. Because for division, we need some other trick, which is not ready to learn for a large part of our class. So today I'm only going to talk about the plus, minus, and multiplication. So let's see how it works. If we're going to calculate, let's just use the number bound. This is one complex number, and then plus another complex number. Then, as I just said, this is simply the plus, the addition of polynomial. So you just open the parentheses and calculate as polynomial. 2 plus 3i plus negative 5 became minus 5, plus is plus I. And then these are the number part. Combine these two, you got 2 minus 5 is negative 3. And then for double underline, you got the variable part, which is plus 3y, I plus I. Together, you got plus 4 times I. And that's it. For plus, is the same as polynomial. And for the minus, it's totally the same. Minus is also 100% the same as polynomial. You just combine the number part, combine the variable part, and then that's your result. But now let's see how about multiplication. Let's still use the same number, but now we calculate the product. So again, as a product of polynomial, you may open the parentheses by FOIL method or by just open them term by term. But no matter which method you prefer, you just calculate the product as a polynomial. Then what you have, first one, you got the outside, the first is negative 10. The first, the outer, 2 plus 2 times I is 2i. Then 3i minus 5 is negative 15i. Then 3i plus 3 times I squared. And then at the polynomial, you just combine the term with the same degree. Because negative 10 is the number part. Oops. Plus 2 minus 15 is minus 13i. And then plus 3i squared. Okay, great. That's the result at the polynomial. But it's not a complex number anymore, because a complex number, as we defined here, let me mark it. The complex number, as we defined here, should be a degree 1 polynomial. But what we have here is a degree 2. So we need to rewrite it as a degree 1. Let me copy it here. in case it looks like a B. Okay. To rewrite this as a degree 1 polynomial, what we need is the rules here. Because now we have the number part, which is good, the degree 1 part, which is good, but we have degree 2 part. And we know that I to the power of any large number equals to one of these four cases, and these are all degree 0 or degree 1. So just going to change, okay, I to the power 2 we have, which is here, should equals to -1. So you just replace the I to the power 2 by -1, and here you go. 3 times I to the power 2 became I to the power of -1. Became -1. And now we can draw on -10, -13 times I plus negative is -3. So after all, we have this is -13 times plus -13i. So that's it. Oh, sorry. That's it. That's how we calculate the product of complex number. Thus, you have a degree product of 2 degree 1 polynomial for I. You can simply calculate them as a polynomial. We got the result here. And after you got the result as a polynomial, you just check, okay, for each term with higher degree, you just check, okay, what should be the simplest case for it. So I to the power 0 is 1, I to the power 1 is I to the power 2 is -1, I to the power 3 is -I. And for larger exponent, you just use what we did previously. Simplify it, then it always be one of these four cases. So after all, every term in your polynomial should be a degree 0 or a degree 1 term. Just combine them as polynomial and that's it. Oh, sorry, just in case, here we go, the parentheses. So that's it. That's about the basic operations on complex number. Today we first introduced in the imaginary unit I with these calculation rules. I is nothing but a variable with these special calculation rules. And next, after we introduce this variable, we can introduce what called complex number, which are complex numbers are just degree 1 polynomial of I, but usually we rather write the imaginary unit I, our variable, at the second place. Then we have the plus, minus, or multiplication for complex number. They are totally the same as polynomial, but when you calculate multiplication, you may simplify your result. Like every term with I to the power of greater than or equals to 2, you can simplify it to one of these four basic cases. So it's either equals to 1 or I or -1 or -I, depending on what's the exponent. And then after all, you got the degree 1 polynomial, which is a complex number again. So that's all I want to talk for today. Let me stop the record and then we can answer questions.